Now, I'm not going to talk about generics and delegates, what those features are all about in C#. It's just beyond the scope of what we're doing here. But the good news is that you really don't need to understand them in order to take advantage of this feature that I'm about to show you. Okay, so what I'm going to be talking about is instead of providing an instance of a class that implements iCompare and therefore provides a compare method, you can simply provide the address of a procedure, of a method, that performs the comparison for you when you call the array.sort method. This procedure has to meet a couple conditions in order for your code to compile, though. The procedure has to accept two parameters of the same type, matching the type of data that's stored in the array. And then it has to return an integer value, representing the comparison of the two parameters. So it returns 0, -1, or +1. As you've seen in other examples where we use the iCompare and iComparable interfaces. All right, here are a couple methods that implement this technique. Each of these two methods implement the two rules that I just mentioned. They both accept two parameters of the same type, and they return an integer value. So, because these methods follow the rules as such required by the array.sort method, you can call them from the array.sort method and bypass using instances of a class that implements iCompare. So what this first method does is it takes those two file info objects and compares the file name and returns that value. So I don't need to build a full class around this logic. And compare size does basically the same thing, but it implements that logic to compare the length. If they're the same size, compare the file name. That determines whether one is greater than or less than the other, and then returns that result. So, much more straightforward code. And here's a method that uses that technique. Once again, get the files, have an array of file info objects, I sort them, and the first time what I'm doing here is I am passing this method. Okay? Strictly speaking, I'm passing the memory location of this method, but by doing that, the array.sort method is able to use that method and call it, and it'll call it for each pair of files, just like, essentially like it was doing when I was previously passing the classes. All right, so that sorts the file in full name order, displays the files, and then I pass the compare size method, and that sorts them in size. So now, when I run this code, I'll select sort files for, which is K, and once again, I have them first in alphabetical order, and then in order by size. So the net effect is the same, but really much more simple and straightforward code. Now, the really good news is that you can use all of these sorting techniques with classes that you create yourself. Up to now, I've been using the file info objects, which is provided by the .NET Framework. But you can create classes that implement iCompare to sort an array of writer objects in multiple orders, or you could create two procedures that handle the comparisons. Okay, and so this next set of code takes that latter approach. So now I'm passing in two writer objects. So again, writer, if I come over to my code there, this is an object that stores simple information about writers, so I can have an array of writers. I pass those in, and then I can call the compare_to method of the name, and now this method fulfills all the rules for being a method that I can pass to array.sort in order to determine the sort order for writers. And then similarly, I have a compare writer home, and this is going to compare the home state and put them in alphabetical order by state. All right, and then here's a method that exercises that. I new up an array of writer objects. It'll have 4 elements within it. I new up a writer, have Don from Alaska, Mary from Florida, Andy from Florida, and Ken from California. And then I call the sort method, and I pass in the array, and I pass in the name of the method. So this code is essentially identical to that last example that I showed you using the file info object. And then I print all the writers and do the same thing to sort them by their home state. And when I run this code, I'll select Sort Writers, which is L, and you can see that now it's sorted by name, Andy, Don, Ken, Mary, and then by home state, Alaska, Florida, California, Florida, and Florida. And notice that I didn't implement any logic if there was a match on state. So this happens to be in alphabetical order, but that's not necessarily going to be the case. I could easily extend that method, though, in order to sort then secondarily by name to ensure that I get them in this order. Now I've shown you a number of different techniques for sorting the data in an array. How do you choose which one is best to use? There's really no firm answer, but there are some guidelines that I can give you. Now, if you're creating your own custom class and you want one default sort order, have your class implement iComparable so that you can simply call array.sort to sort an array of your type. And then array.sort will call at the appropriate time that compare_to method. Or if you want to sort an array of objects and you didn't create the object, so you don't have control over it, you either have to create a class that implements iCompare that provides a comparison procedure and pass an instance of this class to array.sort, or you need to create a procedure that performs a comparison and passes the address of the procedure to array.sort. Or, if you want multiple sort options, you either create separate classes that implement iCompare, or create one class that implements the interface that allows you to specify the sort order as you create the instance. Alternatively, you can create multiple procedures, one for each sort order, and pass the address of the appropriate procedure when you call the array.sort method. So lots of options.